Today we're looking at notes 9-3, add and subtract radicals. So in order to add or subtract two or more radicals, the indexes must match and the radicands must match. Okay, so for example, if I ask you to add 4 cube root of 7 plus 2 square root of 7, you would say, I can't, it's not possible because the indexes don't match. Okay, there's an implied 2 there, which doesn't match with 3. And for example, if I asked you to add 4 cube root of 7 plus 2 cube root of 5, you would say, I can't, because the radicands don't match. Okay, what's under the radical doesn't match. Okay, but if I ask you to add 4 cube root of 7 plus 2 cube root of 7, you would say, yes ma'am, it's 6 cube root of 7, right? Because when you add two radicals, you collect the coefficients, so the numbers in front, so 4 plus 2, which is 6, and you keep the index and the radicand the same. Okay, so let's do a couple of examples here. So if I ask you to add 4 square root of 5 minus 7 square root of 5 minus 8 square root of 5, you can add these because the indexes are the same and the radicands are the same. So that'd be 4 minus 7 minus 8. So 4 minus 7 minus 8, which would give you negative 11 square root of 5. Okay? So if I asked you to add and subtract 8 square root of 6 minus 2 square root of 3 plus square root of 6 plus 4 square root of 3, well, you would somewhat be able to do this. You would be able to add the 8 square root of 6 with the square root of 6, and you'd be able to add the negative 2 square root of 3 with the positive 4 square root of 3. So that would give you an answer of 8 plus, there's an implied 1 here, so 9 square root of 6 plus 2 square root of 3, because 4 and negative 2 would be a positive 2 square root of 3. And that would be your final answer there. Okay, now if I asked you to add these radicals, you would probably at first say, well, I can't, but then I would say, oh, but you can, because you can go ahead and break down. So 27 is 9 times 3, and 9 is 3 times 3. Drag down this 3, so a set of 3's comes out, which would give you 2 times 3, which would be 6 square root of 3, plus, that one just drags down, there's nothing you can do with that, 4 square root of 3, and then 12 breaks up into 4 times 3, and 4 is 2 times 2, drag down the 3, so you have negative 3 times 2, which would be negative 6 square root of 3. Okay, so then you have radicands and indexes that are the same. You can combine. 6 and negative 6 will cancel each other out. So then what you have remaining is 4 square root of 3. It's the only thing left. 4 square root of 3. Okay, let's practice another. So 6 cube root of 16 minus 2 cube root of 54. Well, 16 is 4 and 4. 4's break down to 2 and 2. 54 would be 9 and 6. 9 is 3 and 3. 6 is 3 and 2. So I have a set of 3 2's and a set of 3 3's. So then I have 6 times 2, which is 12. So 12 cube root 2 minus, there's a 2 already here, times this 3, which would be 6 cube root 2. So now my indices and my radicands match. So then I would have 12 minus 6, which is going to give me 6 cube root 2. Final answer. Okay. All right, moving right along. We're making great time. Okay, so number 5. Before we add, our indices match. So then let's go ahead and break these numbers down. 375. So 375 divided by 25 is 15. So 25 times 15. 25 is 5 and 5. 15 is 5 and 3. And then I've got 1, 2, 3, 4, 5 x's here. Well, let's go ahead and finish this one off. So this would be 4 times 5, which is, 20. And then I've got a set of x's here, 3 x's, so x to the first. And then I would have cube root 3x squared. Okay, remember no absolute value bars needed, it's an odd index. Plus, well, let's see what we get here. 24 is 6 times 4. And then 6 is 3 times 2. 4 is 2 times 2. I've got 1, 2, 3, 4, 5 x's. Set of 3 2's, set of 3 x's. So 6 times 2 is 12. And then x. And then cube root of 3x squared. So what's very nice is my indices and my radicands match. So 20x plus 12x would give me 32x. And then cube root 3x squared. That would be my final answer. Okay, moving right along. Breaking this up, 48. 48 is 6 times 8, 6 is 3 times 2, 8 is 4 times 2. Okay, 4 is 2 times 2, drag down the 2, drag down the 2, drag down the 3. So the x, I could drag it down, it's not going to do me any good because it's definitely not going to come out. I've got a set of 3 2's, I've already got an x there. So it would be 2 times x, as you multiply those two things. And then cube root of, a 3 is left, a 2 is left, and an x is left. So 6x minus, okay, 162. 162 is 41 times 4. And then 41, let's see, we can divide, not 7, not 6, we can divide 41, 162, excuse me, 162 divided by 4, that's not going to work, 162 divided by 2, that's why, 162 divided by 2, yes, so 81 and 2, it can't be divided by 4, that's right. So 81 is 9 and 9, 2 drags down, 9 is 3 and 3, this 9 is 3 and 3, drag down the 2, so I've got set of 3 3's, already got a 2 there, let's see, I've got 4 x's, okay, so I circle a set of 3 x's, and so I've got 2 times 3 times x, which is 6x, cube root of 3 times 2 times x, which is also 6x. So when I go to subtract these, 2x minus 6x equals negative 4x cube root of 6x. All right, we're doing great. Okay, so now moving right along, we have cube root 27x, so breaking that up, 9 times 3. 9 is 3 times 3. Drag down the x. Okay, so I've got 3 cube root x, and then 8 breaks up 2 times 4, and then 4 is 2 times 2, drag down this 2, and I've got 1, 2, 3, 4 x's, so a set of 2's, set of x's, so plus 2x cube root of x. So my indices, radicands match, okay? But look at this. When I go to combine this, 3 plus 2x, I can't combine them per se. I cannot put them together. So you would say the answer for this would be 3 plus 2x, because those can't be combined any better than that, with the cube root of x. And that would be my final answer. Okay, let's practice another one. So number 8, cube root 16a to the 5th plus cube root 2a squared plus cube root 54a squared. Okay, 16 is 4 and 2. 4 is 2 and 2, and then 2, and then I've got 1, 2, 3, 4, 5 a's. So set of 2's, set of a's. So 2a cube root a squared, okay, plus cube root 2a squared. Can't do anything with that. All right, 54 is 9 times 6, 9 is 3 times 3, 6 is 3 times 2, and then I've got a squared, which again, that's not going to do me any good, plus 3 cube root 2 times a, so 2a squared. And I made a mistake here, didn't I? Yes, I did, because 4 times 2 is not 16, so there should be an extra 2 here. Okay, hopefully you already picked up on that, which means there should be an extra 2 in here. Yes, because these radicands should match, and there you go. Now they do. So that should have been 8 or 4 times 4, either way, 8 times 2 or 4 times 4, which would have produced 2 times 2 times 2 times 2, giving me an extra 2 to stay in the house here. So when I combine, I have 2a plus 1 plus 3. So that would give me 2a plus 4, because I can combine the 1 and the 3, but I can't combine it with the 2a. Cube root of 2a squared. Okay, and that would be my final answer there. All right, last example, number 9. Okay, square root 9x plus 18 plus square root 25x plus 50. So what you do with these lovely guys is you want to factor out the GCF. So you would take out 9 here, which would give you x plus 2. Then you can break up the 9 to 3 and 3, and because it's square root, 3 comes out, so you'd have 3 square root of x plus 2. And then similarly here, 25x plus 2. 25 is 5 and 5. The 5's pair up and come out, so you have plus 5 square root of x plus 2. So your final answer would be 8 square root of x plus 2. Final answer. Last problem. Yay!